Hello everybody. Along with the various types of in-loop testing which I have mentioned clearly, there are some more types of testing which are included as a part of the ADAS software development. Now let's see those types of testing which play a pivotal role in the development of ADAS functionality and ADAS system. Testing is a critical part of the advanced driver assistance system to ensure safety, reliability and compliance with automotive standards. Okay, so testing majorly is done to ensure whether the functionality is meeting and complying with the automotive standards. So there are majorly four types of testing: unit testing, integration testing, system testing and acceptance testing. Now let's see the scope and techniques which are used in all the types of before mentioned testing. First is unit testing. Unit testing involves testing individual components of ADAS software in isolation to verify their correctness. A unit could be a function, class or module. Understand this word very carefully. To understand this word is extremely important. A unit could be a function, class or a module. That is the smallest component of the software which executes a given application. That is called unit. Alright, now unit tests are usually written down by developers and are designed to catch bugs or errors early in the development. The major purpose of this unit test is to catch the bug at the earliest possible development and at the lowest possible development level. Okay, so that is the purpose of this unit testing, and these tests are typically automated and run frequently to ensure changes to the code base don't introduce new issues. So sometimes as the code base is proactively changed, new issues may arise, and the purpose of this unit testing is to ensure that new issues don't arise and they are curbed in the bud itself. They are nipped in the bud itself. Okay, so what is this key aspects? What are these key aspects? So the key aspects in ADAS is it tests small independent parts such as sensor data processing algorithms, object detection functions. For example, testing a lane detection algorithm with synthetic input images. So testing a particular algorithm for a given use case is called the unit testing. I mean, that falls under the scope of unit testing. And second use case is image processing functions for lane detection or pedestrian recognition. Now this is again a very small use case. So basically this unit testing is testing a given component of the software for a given use case. It can also include sensor data processing for radar or lidar system and control logic for adaptive cruise control or automatic emergency braking. Alright, now what are the various types of techniques that are used for unit testing? Both the techniques are mentioned here. First is white box testing, which tests the internal logic using code coverage metrics. Next is mocking, simulating sensor inputs like radar camera data. And the tools, of course, C++, Python frameworks, model in loop. Model in loop also is a part of the, or rather model in loop is also categorized as a unit testing, because sometimes in model in loop you test a very small aspect of the model also. So that also can be categorized into unit testing. And what are the main challenges when it comes to ADAS? Handling real-time constraints, ensuring robustness against edge cases. All these are the major challenges in ADAS. Now next, see what is meant by integration testing. Now as the name itself suggests, what is meant by integration? So this is a case where more than one unit of ADAS component are integrated or merged into a single system. Now again there is something called system testing. I will explain what is system testing. But integration testing means integration testing checks the interactions between the multiple components modules to ensure they work together correctly. This word interaction is very important. Integration testing checks the interactions between multiple ADAS components modules to ensure they work together correctly. Understand this very carefully. Okay, next, one most important interacting activity which happens in ADAS is sensor fusion. where more than 3 or 4 components outputs are merged to form a single output. Output of radar, output of camera, output of lidar, output of sensor, sonar sensor, ultrasonic sensor are merged to form a one single output. So this is where integration testing comes into picture. And for example, if automatic emergency braking system correctly process inputs from radar and triggers the braking actuator. So in this system, AEB first it receives inputs from radar and triggers the braking actuator. So this whole chain or chain reaction must happen seamlessly. That is what is checked in integration testing. Next is integrating sensor data from multiple sources to ensure accurate object detection, and combining control logic for different ADAS features, lane keeping assist and adaptive cruise control. Sometimes more than 2 ADAS functionalities can be merged or integrated to get a result, to get a single output. That is called combining control logic. Next comes integrating ADAS functionality with other vehicle systems like braking and steering. Now braking and steering are very important. I am sure you would have guessed the word actuators. Brakes and steerings are very important actuators as far as ADAS is concerned, and as I mentioned, there is a separate chapter for all the actuator mechanisms. What are the various approaches? Approaches can be incremental, top down or bottom up, and slowly graduating subsystems. So you test by slowly integrating one system after another. And next is again hardware in loop. Hardware in loop is nothing but you integrate the software and hardware into one particular hardware and then test the entire system as a whole. Next comes the challenges. Synchronization data from multiple sensors, handling communication protocols. Okay, integration testing. You see this drawing. Integration testing is nothing but checking the interaction or the interface between the two modules. So this is called integration testing. Next comes the system testing. Now this system testing is again a slightly higher level testing but a very important type of testing. System testing evaluates fully integrated ADAS system against functional and non-functional requirements. So it can be both functional and non-functional requirements. Functional means some kind of technical actions, and non-functional means it is something to do with the compliance and something to do with the regulatory requirement. Now key aspects in ADAS: end-to-end validation of ADAS features, adaptive cruise control, lane keeping assist. So this comes under the scope of the system testing. Understand this word very carefully. End-to-end validation of the entire system falls under the purview of system testing. For example, testing if the lane departure warning system correctly alerts the driver under various road conditions. So various road scenarios are simulated and checked if the lane departure warning system is correctly warning the driver. This falls under the purview of system testing. Now testing the system's ability to detect and respond to various road scenarios, example lane changes, pedestrian crossings. Verifying the system's performance in different environment conditions, daylight, night time, rain and snow, all these things, testing under different scenarios. This is what I mentioned when I said various road conditions. It not only the condition of the road, like whether it is bumpy or it has a lot of pitfalls, or it is very smooth, or it is snowy, or all the various types of ambient conditions also are included. And also ensuring that the system integrates correctly with the vehicle's other systems. Okay, whether the ADAS, for example, nowadays in high performance computers, the ADAS functionality, infotainment functionality, body control module functionality, all are integrated into one particular hypercomputer, high performance computer. So this integration on the whole is working properly or not, that also falls under the purview of the system testing. Now what are the various types of tests? Functional, performance, safety, robustness, all these things are falling under the purview of system testing. And you can say that all these functional, performance, safety and robustness are subsets of system testing. Okay, and what are the various methods? Software in loop, vehicle in loop, or falling under the purview of system testing. Okay, only model in loop falls under the purview of unit testing. Software in loop or vehicle in loop, for actually even hardware in loop also comes under the purview of system testing, but I did not mention it here because we already mentioned it in the integration testing. Now, while testing these things, these standards IS4 21434, Euro NCAP, these standards are clearly kept in mind, clearly kept in the vicinity of your development to make sure the system testing happens in a seamless manner. Okay, now let's see the next type of testing. Last but not the least, this is acceptance testing. Actually, I would say this is the bread and butter for all the OEMs and tier 1s. Okay, it is only after this acceptance testing is completed that a tier 1 can submit its particular functionality to the OEM. Alright, now what is this acceptance testing? Well, as the word name itself suggests, acceptance testing validates whether the ADAS system meets the business, regulatory and end user requirements before development. Okay, so this clearly validates that the ADAS system is meeting all the business, regulatory and end user requirements, because even if it fails to meet one among these business or regulatory or end user, it cannot be sold and it cannot generate income, and in business generate income is of primary importance. Okay, key aspects in ADAS. What are the various key aspects in ADAS? Alpha testing, beta testing, internal and limited external trials. Next is regulatory testing. Next is customer validation. All these things, all this, and how does the customer validate? By testing the vehicle in real world. If the customer he wants, he can take the vehicle to any highway, any urban places. For example, if he wants to test in a very hot place, he can take it to Rajasthan. If he wants to test in a very cold place, he can take it to some Sweden or Norway, or even, and if you want to test it in a very sparse oxygen level, he can take it to some mountain top like Leh Ladakh. So all these things, all this customer validation, it is a subset of acceptance testing. Okay, next comes to what are the methods. Field operational test, scenario based testing. Now this scenario based testing is a very important thing. Now actually there's a slight fine line between scenario based testing and user acceptance testing, because they both are like how to say, they go hand in hand. NCAP test protocols. Now NCAP has outlined meticulously the various types of protocols, and these NCAP test protocols are very important to ensure that NCAP test is completed and the regulatory body approves your functionality. It is only after you test the functionality through the NCAP test protocol that the regulatory body approves your functionality, and only then it can be sold to the OEM, or it is only then that OEM can actually productionize that particular functionality. Okay, and now this user acceptance test is a very reliable test. Statistics show that it is showing almost 99% detection accuracy, and certification also for mass production. It is only after acceptance testing that mass production is approved. Alright, now let's see the comparison table. I request all of you to pause the video here and see this particular testing in a very clear cut, lucid manner. For example, in unit, what is the scope? Single function module. Integration, multi-module. System, full ADAS feature. And for acceptance, it is end user regulatory. Now here it is clearly mentioning the ADAS examples. For a unit, it is only the signal processing algorithm. For integration, it is sensor fusion. And for system, it is the entire functionality, adaptive cruise control. And for the acceptance, it must meet the NCAP regulations or NCAP certifying protocols. Now what are the various standards? For unit, it is Google testing or MIL or PyTest. For integration, it is HIL. For system, it is SIL, WIL or ISO 26262. And for acceptance, these are all the various regulatory standards that need to be met so that they are allowed into the market. Okay, I recommend all of you to go to the internet and search what is this FMVSS stands for. This is a internationally approved or accepted testing standard for various types of functionalities in the vehicle. Okay, so I strongly recommend all of you to stop here, to pause the video, go to the Google and search this FMVSS. it will give you a clear cut idea the efficacy of this particular standard. And while testing the standard testing ADAS system, it is essential to consider the following factors. First is the safety. The very purpose of the ADAS is to make the vehicle safe. So you have to ensure that ADAS systems are designed to prevent accidents, to reduce severity of crashes. And testing must ensure that system is safe for use in real world driving scenarios. Next comes the regulatory compliance. Next comes the environment factors. Next comes the user experience. When it comes to regulatory compliance, it must comply with all the relevant regulation depending upon the exact location where it is sold. Whether it is sold in Europe or America or Japan, every country has its own compliance standards, and those must be perfectly met so that the vehicle can be sold in that respective market. Next comes the environment factors. All the various environmental factors must be considered. Different road conditions, different ambient conditions, different atmospheric conditions, different road scenarios, and every country has its own driving culture. In a country like Germany, well, traffic is very meticulous, but unfortunately in countries, some Asian countries, traffic is very haphazard. So all these road scenarios must be clearly considered so that the vehicle functionality is developed to the utmost efficacy. Next comes the user experience. ADAS systems must be designed with the user in mind. All said and done, the vehicle is driven by the passenger, and the ADAS system must be designed with the user in mind. And testing must ensure the system is intuitive, easy to use, and it provides a positive user experience. All said and done, it should give a positive, safe, best user interface experience for the user. Okay, let me elaborate. Your system may be very efficient, but if it is not user friendly, well, it won't definitely gain popularity among the riders or the customers. That is the reason user experience is of utmost importance. Okay, so I hope you got idea about all the various types of testing: unit, integration, system, and acceptance. Now these are actually going hand to hand with the various types of in loop testings which I already mentioned. Okay, thank you.